Good day, everyone. I am Miss Louella Degamon from Surigao State College of Technology, Surigao City, Philippines. In this conference, I will be presenting to you our research paper entitled Length-Weight Relationship of Molluscan Fauna in the Mangrove Forest of Barangay Nabago, Surigao City, Philippines. Here are my co-authors in this study from the College of Teacher Education and the College of Arts and Sciences from the same institution, Surigao State College of Technology, Surigao City, Philippines. And here's the abstract of my study with the keywords bivalves, gastropods, mangrove-associated fauna, negative allometry, and shell growth. Mangroves play potent roles in the life cycle of various aquatic organisms. According to Degamon and Carina 2012, they serve as a spawning, nursery, and feeding ground to many organisms, including mollusks, particularly the bivalves and gastropods. They are significant as means of livelihood and for fisheries, yet often neglected in research and management. According to Gomez and Minguawa Linquanan 2006, Huntila Gonzalez and Dolorosa et al. 2014, uncontrolled harvesting and mangrove habitat destruction threaten the molluscan fauna, which are considered to be the most ubiquitous macrofauna in the mangrove ecosystem. McIntosh et al. 2002 highlighted that their diversity and abundance are biological indicators of the dynamic condition in the mangal ecosystem and for in-depth climate change adaptation and mitigation studies, according to Dangan, Galon, and Dolorosa et al. 2014. In fishery management, studies on the length-weight relationship are often conducted. By studying LWR, taxonomic differences and events in the life of an aquatic organisms are determined. Any deviation from the relationship indicates variation in the ecology of the habitat or physiology of the animal or both. According to Degamon and Gamalinda 2021, the bivalves and gastropods from the mangrove forest of Barangay Nabago are collected by locals as an essential source of food and livelihood. Collection of some common gastropods and bivalves are being handpicked, and some are being dug from the muddy soil, causing destruction to mangrove stands as they were being cut to ease the extraction process. Persistent cutting of mangrove trees poses a threat to the existence of mangrove-associated fauna in the said locality. Hence, a study on the length-weight relationship of these gastropods and bivalves is conducted to determine the physiological status of the resources as well as the ecological condition of the mangrove forest in the area, to provide a basis for policy formulation in the conservation and sustainability measures of the molluscan and mangal resources. Figure 1 here shows the study site. 3 stations were identified in the mangrove forest of Barangay Nabago, Surigao City, Philippines. In each station, 3 100-meter transect lines were established, where 5 10 by 10 meter plots with 10 meters intervals were laid. A total of 0.45 hectare mangrove forest served as the sampling site for the collection of gastropods and bivalves subjected to length-weight relationship study. The gastropods and bivalves present in the sampling stations were collected through hand picking. Bivalves firmly attached to the roots and stems of mangroves were taken using scalpel and knife. All collected gastropods and bivalves were placed in plastic containers and brought to the laboratory for identification and measurement. Taxonomic key guides were used to identify the species. Morphometric measurement was done after all the collected samples were cleaned. Vernier calipers at 0.05 mm precision were used to measure the length, while a digital weighing scale with 0.01 gram sensitivity was used to measure the weight of the dried gastropods and bivalve specimens. As to the data analysis, the length-weight relationship of gastropods and bivalves were determined using the power equation W is equal to A times L raised to the power of B, where W represents the total weight, A is the intercept indicating the initial growth, L refers to the length, and B represents the relative growth rates of the variables and provides information on growth according to Leckreen 1951 and Frus 2006. The growth pattern is determined through B values. When b is equal to 3, growth is isometric. That is, the increase in length follows an increase in weight. When b significantly differs from 3, growth is allometric. That is, increase in length may result to a decrease in weight or vice versa. A negative allometric growth pattern is exhibited if b less than 3, while a positive allometric if b is greater than 3. Descriptive statistics and analysis of relationships were done using the statistical package of Microsoft Excel 2016 version. In this study, Table 1 presents the parameters of the length-weight relationship of bivalves from the mangrove forest of Nabago. A total of 98 bivalve individuals belonging to two families, Lucinidae and Ostridae, were collected from the sampling stations. The total length and total weight of Anodontia edentula has a mean of 4.12 centimeters and 19.01 grams respectively. Saccostrea cuccullata, on the other hand, has a mean total length of 4.45 centimeters and a mean total weight of 3.31 grams. The two bivalve species under separate families exhibited an allometric growth pattern. A. edentula demonstrates a positive allometric growth with B value of 3.70, while S. cuccullata presents a negative allometric growth pattern having the B value of 2.61. This difference may be attributed to the type of bivalve they belong to and the type of substrate they live on. A. edentula are infaunal burrowing bivalves residing in muddy substrates of the mangrove forest, while S. cuccullata are epifaunal bivalves firmly anchored and crystallized on the roots and trunks of mangroves. The positive allometric pattern, considering the total length and total weight of A. edentula, conforms to the findings in the study of Degamon and Gamalinda 2021, Piteta et al. 2019, Perez and Centelli 2018, Tura et al. 2018, Elvira and Humawan 2017, and Park and O 2002. According to Perez and Centelli 2018, this positive allometric growth pattern is common to infaunal burrowing bivalves. Growth pattern of S. cuccullata with a B value of 2.61 indicates that its length increases faster than its weight. This result conforms to the study of Aban et al. 2017 on the length weight of Perna viridis, or Asian green mussel, an epifaunal bivalve from Bolinao Bay, Pangasinan, Philippines, and in the study of Sundaram et al. 2011, where the B values obtained by these authors varied from 2.41 to 2.86. It has to be noted that whatever growth patterns these bivalves have, there are several factors influencing them. Their growth and morphometry may be affected by both environmental factors such as current, depth, temperature, wave exposure, and sediment, and biological factors like predation and burrowing abilities, according to Gaspar et al. 2002, Bimen et al. 2004, Bobby et al. 2010, and Tura et al. 2018. Moreover, it is presented in Table 2, the parameters of the length-weight relationship of gastropods found in the mangrove forest of Barangay Nabago. A total of 866 individuals belonging to 4 families were collected from the sampling sites. Both Littorinidae and Putamididae families have 3 species each, namely Littoraria angulifera, Littoraria melanostoma, Littoraria scabra, Ceridite diculiata, Terebralia palostres, and Terebralia sulcata respectively. There are also 2 species under each family of Muricidae and Neritidae. These are the Chicorius caponicus and Tingilla musiva for Muricidae family, and Nerita ixovia and Nerita lineata for family Neritidae. Among the 11 gastropods, species in Insovia and Lineata, T. palostres, and T. sulcata are among the most numbered individuals. They are commonly found on the lower trunks and exposed roots of mangrove stands. It can be gleaned from Table 2 that all gastropod species exhibit negative allometric growth pattern with the B values of less than 3. This indicates that gastropods' shell length increases faster than their weight. Suchin and Stanton 2001 noted that marine gastropods need strong shell strength to have a high capacity to live in unfavorable environmental conditions and as an adaptation to environmental stresses. Mendoza et al. 2019 also highlighted that the allocation of energy shell growth is higher instead of the soft organ that shifts growth into a negative allometric pattern. During the sampling, researchers observed that the cutting of mangrove stands and over-harvesting of shellfishes are still practiced despite restrictions from the government agencies and the local government units. To conclude, the length-weight relationship of bivalves and gastropods from the mangrove forest of Barangay Nabago showed an allometric growth pattern. For bivalves, A. edentula exhibits positive allometry, while S. cuccullata shows negative allometry. For gastropods, all 11 species demonstrate a negative allometric pattern. These differences in the allometric growth pattern may be attributed to the environmental and biological factors currently influencing in the sampling site. Results of this study may provide baseline information in the conservation and sustainable management of the mollusk resources in the area. This study recommends that further studies may be conducted on reproductive growth and resource assessment for possible aquaculture cultivation and production. These are the references used in the study. And that would be all. Thank you. At this time, the presenter is now ready for questions from the panel and the audience.